I don't share much about PeopleRain with our community, but I'm going to break protocol. PeopleRain is the product version of the ethos behind this great Team Human community. Our team is passionate about giving the next billion employees back 4 to 6 hours of productive time per week. Hundreds of organizations around the world trust PeopleRain to automate work because it's the safest, most trustworthy, and smartest way to automatically execute thousands of common IT and HR tasks. Consider it the antidote to AI that's either creepy or that poses a threat to human jobs. I'm hosting a live webcast where I will show a demo of agentic AI in action. Register for the webcast at peoplerain.io. That's people, reign like the reign of a queen or king.io. Now back to this week's amazing episode.
Yo, it's the future, don't hit the snooze. AI is here giving humans the boost. Team Humans rolling, brains in the game with Dan Turchin. Y'all remember the name. People reign in the mix, no stopping the flow. Better work, better life, yeah, we're ready to go. Robots and humans, a collab, you know. Okay, let's start the show.
This is Dan Turchin from AI and the Future of Work. Welcome back to a special edition of the podcast featuring conversations recorded live at the HumanX 2026 event in San Francisco. This is the second and final compilation of our 3-part series highlighting the incredible founders and visionaries we met at the event. As always, we're using 11 labs to digitize my voice for this compilation. The real me reviewed and approved the content and, of course, approved the digital twin. Our first compilation highlighted how AI amplifies the human potential it can never replace. Today, we shift to the technical side and hear from leaders wrestling with a critical question. How do you build AI systems you can actually trust not to fail when it matters most? As technology increasingly infiltrates life-impacting areas, these 4 builders explain how they are designing AI for accountability, safety, and harmony between humans and machines. Let's begin with Christine Yen, CEO of Honeycomb.io. Christine discusses the shift toward observing real outcomes rather than just reading code, reminding us that system metrics don't matter if your users aren't happy. She also shares why organizations need to start defining AI values to establish norms for how we engage with and review the work produced by agentic workers.
We were brought together by this idea of different perspectives trying to make sense of what the heck the software is doing. And that's something that is, you take that ethos, bringing production and development closer together, and you carry it forward. And that holds true whether it's humans authoring the code, agents authoring the code, whether it's humans or agents or both debugging that code. I think this acknowledgement that we are building for teams of mixed perspectives is actually carries really well forward into an agentic era where now the code, we think the code never really was the source of truth. A lot of folks treat the code as like, this is the truth of what's going on. Our thesis is always, you can only test in production. That was true in the cloud era, we believe. In the AI era, that's even more true. No one is reading the code anymore. No one is laboriously building a mental model of what the code is supposed to do. You can only observe the outcomes and be really intentional about what should the code be doing? What does good look like? How do we notice when reality deviates from our expectations? So I think because we've always felt this core imperative so deeply in our bones, and always been so interested in that intersection between technology and how people use it, the socio-technical interface. It means that, as these techniques and tools and technologies swap out, we get to just keep sort of working this problem with newer and better tools to attack it with.
So as life is infiltrated by technology, it has already, it will be more in the future. Our aging parents will rely on technology for monitoring their health, and technology drives us around, and it will be our surgeons and really like life impacting stuff.
Yeah.
Measuring, monitoring the quality of that technology
that has these really life impacting implications will get more important. So I said softball question, but would love to get your perspective on, where Honeycomb goes when it's that important, the stuff you're doing.
It's funny that you're calling that a softball question because it's such heavy material. I'll say maybe 10 years ago, 15 years ago, logging, monitoring, APM, these tools were often very focused on really granular aspects of a system. How's my disk space doing? How's CPU utilization? Is the throughput on this endpoint within what it bounds? Really very much looking at individual parts of the proverbial elephant. And a thing that has happened in the last few years that I think is really positive is elevating that question that we're asking. Instead of here's a small facet of the system, is it operating within bounds? It is learning to ask, how is the system operating and how is it serving the needs of my customers? One of the things my co-founder loves to say is nines don't matter if your users aren't happy, right? Some minuscule aspect of your system performance does not matter if it's not, safely driving on the streets, or if it's not, correctly handling home care for a patient. And I think that trajectory of us as technologists being able to see that bigger picture and connect some aspect of the code or software or system to the impact that we're hoping to drive, I hope that trajectory continues.
One of the things we talk a lot about on this podcast, but in this community, it's responsible AI. And I'd love to know from your perspective as CEO, what does that mean to you, and how do you kind of operationalize those, a set of principles in your organization?
That's a great question. I think that companies have, for a long time, held a practice of defining values for the company, right? This is how we should interact with each other as people. This is how we, how we should approach our work. I think that Honeycomb is working on formalizing, and I think many companies are going to have to define what are our AI values. The same way, there are guidelines and expectations about how you treat your human coworkers. There should be some accepted guidelines on how to engage agentic workers, on how to present or challenge or engage with work produced by those agents. Maybe there'll be a world when there's sufficient societal norms. Chances are most companies, I can't just walk in and, I don't know, stab someone. Like, that's just pretty universally accepted.
You went there.
Yeah. That's sufficiently accepted on a society level that no company has to embed that in their values. I think that will eventually happen with AI work. Right now, I think it's really useful for companies to think about, if someone is presenting a deck that Claude helped them build, what level of disclosure, if any, is necessary? What level of editing, if any, was necessary? How should people think about human attention on the other side? If I'm able to produce a 16-page document with AI, that's wonderful. Is it responsible for me to put that on your desk and expect you to read it with your human eyeballs? Or actually is it an expectation that you are going to use your agent to parse it for your human brain? I don't know. Those are norms that are going to have to be set by each company right now.
Next, we hear from Dr. Ali Agha, CEO of FieldAI. Ali takes us into the physical world, exploring how robots are designed to augment human limitations in dirty, dull, and dangerous environments. He explains how building trust on a job site requires robots to calculate their own uncertainty, ask questions, and seamlessly communicate their intentions to human coworkers.
One of the challenges of bringing AI into the physical world is that the physical world has traditionally been occupied by humans. Part of the hard part is what you're doing, creating the technology. But there's also a hard part in being a human and coexisting with robots. Talk us through how you think about that part of the challenge of what you're building.
Absolutely. We see human robot interaction as a very core and critical part of our mission. The architecture of our models or the software that sits on the robots by design calculates and measures the uncertainty and confidence in every action, every inference it makes. Meaning that if robots want to take an action, if it understands something, it also reports to you how confident it is. And the reason I mention this is the backbone of how we architect the human robot interaction. Because if as a robot you're uncertain about something, you can ask questions from a human, from another robot, from another compute source, and this creates a very natural dynamics between human and robot to make decisions together and react. So that's sort of from the technical and architectural perspective on how and when sort of the interaction between machine and robot gets established. And in terms of the harmony of them being in a job site and together in the environment, it's very critical for the robot to share the intentions and what it's going to do so that the human is aware and this interaction becomes seamless and very natural.
There are 8 billion of us here on the planet to do human tasks. What we need help with is the things that humans aren't good at doing. And oftentimes that's, lifting really heavy things or being in places that are unsafe for humans. And I like that as a leader in the field, you're thinking about augmenting the limitations of humans.
100%. In fact, in FieldAI, our focus, the market we are going after is what we call DDD, dirty, dull, dangerous. And exactly as you said, we are seeing a lot of opportunities to make the job site safer for people. Right? In construction alone, a subsector of construction, in the US alone, you have 40,000 severe injuries per year, more than 1,000 deaths. And as you mentioned, if you have a device that helps the human to just lift a little bit heavier thing and have less injuries. If you have a device that goes and finds, here's a cliff, you forgot the barrier. Here's a slippery surface, right? And here's this scaffold needs an inspection at this point, right? It just would be making the job site more productive, safer, and 100% agree that these machines, the philosophy should be to expand human capacity, right? So we always are, the dreams of human, there's no bound. We can do a lot more. We can build a lot more. We can do, right? And having systems that helps us get closer and faster to our dream, like expanding capacity, I think is the way we should be looking at these machines.
There's so many unintended uses of robots that FieldAI builds or could build in the future. How do you think about the unintended uses? Do you take responsibility for the ways that customers could use these very powerful machines that are kind of out of spec based on the way you designed them?
Almost any technology, a bad guy or less careful person or somebody who is too optimistic can take and misuse it, cause harm. We are trying to stop that from happening, prevent it, minimize chances by making sure we qualify the people who have access to these and making sure that they're well trained. They understand these machines and solutions at the highest level. But then also at the lower layers of the autonomy itself, there are many, many layers of safety are baked into these systems. The system looks at the geometry around itself and knows, the distances and forces and everything to avoid, physical touches or interactions that might be hurtful. It analyzes the world semantically. It understands, this is an object and chair, that's a human. This is a moving car. That's a scissor lift. That's a truck. It goes beyond that. It understands the world contextually, not just the objects, but what is the relationship. So the robot behavior would change if a human is on a ladder versus human next to ladder, because that, although the same objects, but there's a different context and relationship. So all of those are big and getting big into the solutions so that these systems become like a colleague on the job site, somebody who you can trust. And that's where, again, goes back to the architecting them in a way that they can represent uncertainty, represent and communicate their confidence in everything, that in turn feeds back into their decisions and adjust their carefulness, speed, and the balance between how they execute tasks versus how much they spend energy to collect more information before they commit to an action.
Our next guest is Dr. Yemi Lian, co-founder and chief scientist of Archetyp AI. Yemi dives into the challenge of separating signal from noise in machine data. She explains why having a human in the loop isn't just a feature, but a requirement ensuring that physical AI models can explain their underlying reasoning before taking any autonomous action.
Every machine today and increasingly in the future will constantly beacon off data and almost all of its noise. You're one of the world's experts in this. Talk about the role of AI in distilling signal from noise when it comes to machine data.
Yeah, that's a really good question. And I think I come from a signal processing background. So much of signal processing theory and fundamentals is exactly this. How do you actually separate out the signal from the noise? Especially in radar, actually, there's a huge field of just trying to distinguish not even noise, but clutter. So signal that isn't relevant to you from signals of interest. And I think with AI, what the promise is that these types of differentiation of the signal components can be driven from data alone. And so fundamentally, what AI can be used for is to discover structure within these signals without having to predefine what that structure is. You can discover patterns that appear repeatedly. There's some sort of temporal recurrence or persistence to them. And that, there's been so much work, even in my own education, about how you can design these heuristics and algorithms in order to do that. What we're saying is now a machine can discover how to do this from the data and from its sensor observations by itself. And so fundamentally, what we believe is that, this layer of intelligence that can sit on top of, as you said, all the existing sensors today that are measuring different physical parameters, different internal and external conditions to the machinery, it can be used without necessarily having to predefine what it is that the signal of interest is. The machine can discover that structure on its own and turn it into some machine native concept of the way that it behaves and its different states of operation. Our model is exactly designed to do this. So it takes in diverse types of sensor data. It's able to represent that data into one common structured latent space. And then on top of that latent space, build an understanding of the different operational states of the system and how they transition to each other. And all of that can be done without having to inject human labels of what those preconceived states from our perspective should be.
Once the algorithm detects, let's say, an anomalous pattern, it identifies the pattern correctly, doesn't a human need to go in and assign some meaning to the pattern before you want to make any decision based on just the brute force acknowledgement that there's an anomalous pattern?
Yeah, that's a really good question. And actually what we've seen from a lot of our existing enterprise customers is that before they want to give AI full autonomy and closed loop control, they want to build confidence by having a human in the loop, exactly for this reason, to make sure that the action that we want to take is appropriate for the meaning of the anomaly as it appears. And so that's why I think it's actually really important to have these models that are designed to have a human interpretable interface. We don't necessarily want to go straight to an action model.
We want to go to a reasoning and communication model that can develop its own understanding of the underlying system dynamics and behavior, and then be able to communicate that to humans, be able to epistemically reason about it, and then explain that reasoning to a human operator or to a human collaborator. And that, I think, is one of the big distinctions between what we're trying to build and, for example, a robotics model, which maybe is action-oriented and task-oriented, not necessarily designed for communicating to a human what sort of epistemic reasoning happens under the hood.
How do you think about ethics, all the implications of things that are really hard to build in when we're just building software, in a pre-AI age of kind of heuristics-based development?
Yeah. And I think this gets to the earlier question that where we see immediate value, but also what makes sense from the safety and security and confidence building stage is that there's this first phase of human in the loop. So machine being able to explain its underlying reasoning to a human so that it's not just direct to action that a human has no control over. And so we see this machine/AI human collaboration as not just a feature, but a requirement. The machine shouldn't be able to just blindly take action at this stage without being able to inform a human of why it's taking that action and what its own understanding of the underlying reasons for taking that action should be.
On this podcast, we talk a lot about responsible AI. All of us that are building an AI have to not just answer the obvious question, which is what could go right, but what could go wrong. When I was preparing for this, I was just spinning on all the, how you might answer that question. Now I have a chance to ask the expert. What could go wrong, and how do you think about ethical boundaries?
I think one aspect of this is we have to be able to objectively evaluate the model's capabilities and the limits of its performance. And so one of the objectives that our company has this year is to build a benchmark for physical AI, and specifically the areas that we're trying to address. And this should be informed by, not just existing benchmarks that exist today for LLMs, but what are the, specific characteristics of dynamical physical systems where you need to detect things that might have great significance in terms of downstream impact, like anomaly detection or physical states of the machine. So that's one aspect, developing objective ways to actually quantify and measure this performance so that we have some degree of assessing how trustworthy the model is. I think the second aspect is, I was mentioning, interpretability and explainability. So there has to be the ability to understand where the model is coming from, where it arrives at certain decisions. And I think these are things that have to be, you have to define over the course of development that these are priorities. They're not something that can be added in after the fact.
Finally, we turn to XD Huang, Chief Technology Officer of Zoom. Drawing on decades of experience in speech recognition, XD explains how the industry is moving beyond basic transcription to solving the entire workflow from conversation to completion. He breaks down how building agentic AI has evolved from early prompt engineering to what is now known as harness engineering.
I was working on speech recognition with a thing, very simple goal. This is the most natural communication mode for every citizen, whether you are Chinese or not. For Chinese, it was even harder because the keyboard was designed for Western language. You have to convert into pinyin. So it's actually harder. That was 40 years ago. I never stopped working on the same problem. I believe this is really going to change how people interact with AI. So when I was on the Microsoft, I helped to lead Microsoft team for the first time in the industry, reaching human parity in transcribing conversational speech. This was in 2016, around that time.
As technologists, and certainly as an expert like yourself, you would probably agree there's a lot more innovation up ahead. What are some of the hard problems that we haven't solved yet?
So I think if you look at the whole chain from conversation to completion, you need a host meeting, Zoom just works. You need to transcribe audio into transcription. Zoom Scribe API powered up Zoom closed captioning and AI companion. Just works. Of course, just like human, with some strong Scottish accent, you may miss one or two words, right? Then after that one, we have deep reasoning. If you take this speech technology for customer support, there's a really famous benchmark, what we call how-to benchmark. They measure the interaction in terms of customer support. Once again, Zoom AI is a SOTA, is on the top tier. So from speech recognition to conversation management, understanding how to engage with customer, that will combine the language self-learning adaptation, how you apply agentic system design. We're also in the forefront. If you want to actually move forward a little bit, the real IQ ceiling is the humanities last exam. So Zoom is able to federate the frontier model, very much like a CEO is trying to assemble a team with multiple people working together. The outcome is better than each individual. Zoom federated approach to AI apply the same philosophy to bring Gemini, Anthropic, OpenAI all together working as a team. The outcome is actually better than each of them. So on Humanity last exam, just before the Christmas last year, the team delivered a major Christmas gift to the community. Zoom, for the first time, performed the Humanity last exam better than the leading model at that time. So if you look at the whole chain, from conversation to completion, you also need to really perform agentic search. Agentic search, as you know, Gemini 3 Pro define the best search capability. A different frontier model, they have a different strength. Anthropic is very good at coding. OpenAI is very good at general reasoning. And Google Gemini is very good at web search. So when Google launched Gemini 3 Pro, they defined the deep search QA agent benchmark. Once again, with our federated approach to AI, we offer the SOTA, agentic search. So in this whole chain of each individual component, Zoom has matured the muscle to deliver end-to-end experience to be unmatched. We just need to really work together with our partner customers to help people from conversation to completion. So that capability of each individual is already there. So in Silicon Valley, in terms of agentic AI, people are now using the term harness engineering. That transformed from early days of prompt engineering to context engineering to harness engineering. That reflected the journey, how the agentic AI application community embraced frontier models. In the early days, people just wanted to optimize how to prompt. Now they realize that the rich context is important. Now people realize, wow, it's not just about rich context. It's how you manage everything else beyond frontier model. So when Zoom introduced federated approach to AI 3 years ago, we already took that systematic approach. We brought a frontier model and our own small model all together on the most important workload. That is AI meeting summary. We delivered the frontier model accuracy with 20x cost saving. Did you hear me? Competitive frontier model quality, 20 times more efficient.
These conversations from HumanX 2026 remind us that building powerful AI is only part of the equation. The true goal is expanding human capacity responsibly and safely. As we've heard today, earning trust in this new era requires intentional design, whether that means observing real-world outcomes over raw code, ensuring machines can communicate their own uncertainty, requiring explainability before autonomous action, or engineering highly efficient federated systems. The future belongs to those who build with accountability at the core. If any of these perspectives resonated with you, listen to the full live conversations. Links are in today's show notes. Thank you for listening to this special 3-part series of AI and the future of work, featuring our hand-picked highlights and best moments from HumanX 2026. Until next time, keep building with purpose.
Yo, it's the end of the show, time to power it down. AI's the sis, but humans wear the crown. Team Human in the house, got the vibe so clever. Dan Turchin from People Brain, making us better. We learned about AI for humans. We're ready to conquer the future, that's all for now. See you next time.